given that real numbers a, b, and c satisfy these two equations, find the maximum value of ab plus bc plus b. Now, this problem is a very good example of how we can use tools that aren't immediately related to the question to solve it. And in this case, we can actually use trigonometry. Yes, I'm being 100% serious. If that surprised you even by a little bit, then watch this video. I'm sure you'll find it very, very interesting. So how can we even start by using trigonometry? Well, it starts by being familiar with our trigonometric identities. What trig identity represents or resembles something squared plus something squared equals to a constant? The Pythagorean identity. Notice that this almost looks like sine squared theta plus cosine squared theta equals to 1. This first equation almost resembles this. But this is 1 and this is 2, so how are we supposed to, relate these two? Well, normally we would probably do something like let a equals to sine theta and b equals to cosine theta. But because this is equal to 2, we can actually let a equals to root 2 sine theta. And we can also let b equals to root 2 cosine theta. And notice that when you plug these two into the equation, this is satisfied by the Pythagorean identity. So we know that these two let statements are valid. Now, because b is equal to root 2 cosine theta, then this second equation would be read as 1 plus c squared equals to 2 over 2 cosine squared theta if we make this substitution. Now, we can cancel 2 on top and bottom, giving 1 over cosine squared. What is 1 over cosine squared? It's secant squared, right? So, if it's secant squared, then let's immediately replace that. Now, this looks very familiar with another trigonometric identity. Specifically, the trig identity that I'm looking for is 1 plus tangent squared theta is equal to secant squared theta. Well, what are you waiting for? Let's replace, or let's let c equals to tangent theta. And we know that these three substitutions are valid. They satisfy these two equations. And the benefit is that we get to express a, b, and c in terms of one variable, theta. So this is much more easier to work with. So how do we find the maximum value? Well, let's plug in a, b, and c with their trigonometric equivalents. AB would be equal to 2 sine theta cosine theta. BC would be equal to root 2 sine theta. The reason for this is because tangent of theta is equal to sine theta over cosine theta. And so b times c, the cosines cancel out, and you just have root 2 times sine theta. Now, b is just root 2 cosine theta. And now our question has just been transformed to find the maximum value of this expression, which is much easier because, again, we only have one variable, theta. Now, at this point, you might be thinking like, okay, well, let's take the derivative. And yes, we can go with derivative if you want to, but there is another method that I want to use because it is much more elegant and it's faster, okay? So, 2 sine theta cosine theta. This over here can actually be condensed as sine of 2 theta because this is the double angle formula for this. And over here, we can factor out the root 2. All right? So that's root 2 times sine theta plus cosine theta. Now, observe that sine 2 theta, its maximum can be achieved when theta is equal to pi over 4. And this would give a maximum value of 1, right? That would be sine of pi over 2, and that's 1. Now, what is the maximum value of sine theta plus cosine theta? Of course, there's a root 2, but that doesn't matter. All we want to focus on is maximizing the variable part. Well, this over here can actually also be achieved at theta equals to pi over 4, and its maximum value is root 2. Now, in case you are confused on why this is true, I'll show a quick proof of it. the quick proof I'll show is, first, consider that this expression, sine theta plus cosine theta, this expression is the same as sine theta plus cosine theta squared, and then you just take the square root back. Now, I know this is a positive square root, but we're assuming the maximum should be positive anyway because there are positive values of this expression. So now that we have the equivalent of this expression over here, we can now expand what's inside the square root. This is a binomial squared, so we just get the square root of sine squared theta plus cosine squared theta plus 2 sine theta cosine theta. Now sine theta plus sine squared theta plus cosine squared theta, that's just 1. So that would be 1 plus, and 2 sine theta cosine theta, that's the double angle formula. That would be sine of 2 theta. But wait a minute, over here, all we care about is maximizing sine of 2 theta now. Well, that is achieved at theta equals to pi over 4. Well, at least it's one possible value. And this would give you 1, of course, because max value of sine is 1. So there we go. The maximum value for this is at pi over 4. And you can see that plugging pi over 4 either into this expression or this expression would yield root 2. So therefore, we know that the maximum value, since both of them can be achieved at the same value, and that same value achieves the maximum value of both expressions, we must conclude that the maximum value is indeed 1 plus root 2 times root 2. So we have our answer. The answer is 1 plus root 2 times root 2. And this would evaluate to 3. Now 3 is our answer. So that's an example of how you can use trigonometry to simplify a problem. In fact, we can use trigonometry in a lot of areas to relate two variables that might look different, right? This expression now just becomes an expression in terms of one variable, and we managed to solve it. And you can clearly see that such a value is possible because if you were to plug in pi over 4 for theta over here, you would see that a, b, and c would have to be 1 each. And 1 for each of a, b, c does satisfy these two equations. And we showed that the max is 3. So, or at least we showed that it cannot exceed 3. And we showed that it can achieve 3. So therefore, the maximum value is 3. Just a side note. Alright, so thank you very much for watching this video. And before I say goodbye, I do want to also challenge you to find a solution without trigonometry. Yeah, try it for yourself. Anyway, thank you very much for watching this video. If you found it interesting, then please do consider dropping a like and subscribing. Thank you very much. Bye.